we're looking at here, we're looking at the rest of graphing rational functions. So there is a 5-step process to graphing or finding items from a rational function. So first one is to simplify the function, which means we're just going to factor top and bottom. X-intercepts are anything in the numerator, any factors in the numerator that we take and set equal to 0 and solve for x. That gives us our x-intercepts. Vertical asymptotes are found by taking the factors of the denominator and setting them equal to 0. Solve for x. That would give us the vertical asymptotes. We looked at that before. The different thing here is if anything cancels out, we're identifying this as a whole. And this is the last, well, kind of the last step. Last thing I want to talk about, but I've been talking about it for a little bit, but anytime we cancel something out, the function is still undefined at that value. But if you were to graph in your calculator the equation, you're not going to see a hole. But down here, it says we indicate holes on a graph with an open circle. So when we graph it, that's where we're going to put. All right, but your calculator is not going to show it. So x coordinates given if we take the thing that we cancel out, set it equal to 0 and solve for x. And then what we have to do is we have to find the y coordinate, we have to substitute the x value into the simplified function to get the y value. All right, so we can get a coordinate for the whole. And then the big thing here is horizontal asymptotes. So we have 3 different rules that you have to know. So if we're given a function f of x equals a of x over b of x, so we have a polynomial divided by a polynomial, that's a rational function. If the degree of a is bigger than the degree of b, so top is bigger than the bottom, okay, so top bigger than the bottom, we have no horizontal asymptote. If the degree of the top is less than the degree of the bottom, then y equals 0 would be the horizontal asymptote, so our x-axis. And then degree of the top is equal to the degree of the bottom. We have to divide our leading coefficients to find the equation for our horizontal asymptote. So refer back to this list as we're going through some of these problems to help you out. So first thing we want to do is factor out top and bottom. So factors of the top, x plus 3, x minus 2, over factors of the bottom, which is already simplified for us. So we factor out the bottom. Now we look if anything cancels. So nothing cancels with each other on the top and the bottom. So we can say that there's no hole. We could write none. We could write NA. That's fine. Either one works. So now x-intercepts, we look at the top. We set those factors equal to 0, solve for x. So we have x-intercept at -3 and a 2. Vertical asymptote, we do the same thing with the bottom. So we have x equals 1 for vertical asymptote. Horizontal asymptote, we look back at the original. We have a degree of 2 over a degree of 1. So top is bigger than the bottom. This means we have no horizontal asymptote. So again, NA or none or no. The domain, this is something else we have to just think through, or just remember. The domain deals with any x values. So we have x values here at the vertical asymptote. So we know that the function would be undefined if x were 1. And then the other one, so vertical asymptote's 1 that we look at for domain. So let me just go ahead and mark that. Vertical asymptote domain, and then the holes, if there's any holes, that would fall in for domain as well. So we have all x's such that x cannot equal 1 because of our vertical asymptote. And now the range deals with horizontal asymptotes and hole. Right. So there's no horizontal asymptote, there's no hole. So what we can say for the range is that it's just all y values, or all real numbers for the y. And that's that. So let's move on to the next one here. So factored out top and bottom. So we have x plus 2, x plus 5. Bottom would be x plus 2, x minus 2. So we look to see, after we factor, what cancels out. Well, x plus 2's would cancel out. So those go away. And a hole is created whenever we cancel something out. So we take what we canceled out, set it equal to 0, and solve for x. So we have a hole, and we want to find the coordinate. Oops. So we have the x value of the hole would be -2. Now we have to find the y. So if we plug -2 into the simplified function, so -2 plus 5 is 3. -2 minus 2 would be -4. So we have -3/4. Right? So that's a coordinate for the hole. X-intercepts, anything remaining on top, we set equal to 0. Solve for x. And then vertical asymptote we know would be at x equals 2 from the bottom. Horizontal asymptote, we look back at the original equation. Degree of 2 over degree of 2. So that's where we take the leading coefficients of each polynomial and divide them. So 1 divided by 1 is just 1. So we have a horizontal asymptote at y equals 1. Now if this were a 5 and this were a 4, it would just be y equals 5/4. Alright. Domain, remember we talked that it was the vertical asymptote and the hole dictates what our domain is. So our domain is all x's such that x cannot equal. So 2 for the vertical asymptote and then -2 for the hole. So -2 and 2. Now our range, all y's such that y cannot equal. So over here we have this marked, horizontal asymptote and the hole. So horizontal asymptote is 1, so we can't equal 1. And we can't equal the y value of the hole, so -3/4. So -3/4 and 1 is excluded from the range of the function. Alright, next one. X plus 1, that's factored. Bottom factored out would be x equals 4, well, x minus 4, x plus 1. Right. X plus 1's cancel, so we have a hole at -1. If we plug -1 into the simplified function, which I want to rewrite this one because there's nothing remaining on top, but there is still a 1 here because everything up here is multiplied by 1. So don't just think that cancels and is a 0, or we just have x minus 4. X minus 4 has to stay on the bottom. So if we take our simplified function, plug -1 in, we get 1 over -5. So -1/5. Alright, now we can talk about x-intercepts, which anything remaining we set equal to 0 and solve for x. Well, there's no x on the top, so that would tell us that there is no x-intercepts. Alright. Vertical asymptote, we look at the bottom, so we have a vertical asymptote at x equals 4. Horizontal asymptote, the original equation, top degree is 1, bottom degree is 2, so top is smaller than the bottom. Horizontal asymptote at y equals 0. So we have a horizontal asymptote at the x-intercept. That's why we have no x-intercepts. Okay. Now talking about the domain. It's all x is such that x cannot equal. So vertical asymptote 4 and whole would be -1. So we have -1 and 4. Range all y such that y cannot equal. So horizontal asymptote and y value of the whole. So -1/5 and 0. Alright, so that is what we need to do. So let's look at a couple more examples here and then we'll be done. So this part we just have to sketch the function. And I'll do one of these for you guys. I think we'll see how this one turns out. So factor at the top, we have +2 -1. And the bottom, -4 +2. Okay. X plus 2's cancel. We're left with that. So we have a whole at -2. If we plug -2 into here, we get -3 over -6, which would just be 1/2. Intercepts, x-intercepts, we have x equals 1, and vertical asymptote would be x equals 4. Horizontal asymptote, we have the same degree, so leading coefficients would be 1 over 1. So y equals 1. And then domain in the range. All x is such that x cannot equal 4 and -2. And then the range would be all y's such that y cannot equal 1 and 1/2. Okay, so that's the same thing we did in the first 3 examples, and now we just have to graph a graph. So we can graph our x-intercepts, so we know we cross at 1. We have a vertical asymptote at 4. So we can draw that dotted line or dashed line at x equals 4, and then we have a horizontal asymptote at 1, so we can draw our horizontal. We know we have a point here, so we have a hole at -2 and 1/2. So our hole is like right here. So we can draw an open circle here. And now all we have to do is roughly connect these. So we go, remember, we're following the asymptotes. So we approach those asymptotes but never cross it. So those will be here, and then we have this curve up here. Now, I talked about this before in the other video that we could plug x values into the equation to find more accurate y values to get a better curve. Not necessary for right now. So we just have to have the idea of what we're looking at on this equation. And actually, we know this one was down here because of the x-intercepts. We know it was in this quadrant, but we do have to figure out where the other one goes, because sometimes it's going to flip around. Okay. So we know at 4 we had the vertical asymptote, so let's plug in 5 to see if it's on the top or the bottom. So if we plug in 5, we have 4 over 1, so we have 4. So we know that the point is on top. Okay, so we know it's right there. So I was right. But again, sometimes the curve is going to be down here in this quadrant. So it's a little bit different from our last video for those reciprocal functions. Alright, so next one we have x. Let's see. X minus 6, x minus 1. And then the bottom is x minus 6x plus 6. X minus 6 cancels, so we have a hole at 6 something. So we're going to plug that into our simplified equation. So 6 goes in, we get 5 over 12, so 5/12. X-intercept at 1. Vertical asymptote at -6. Horizontal asymptote at y equals 1. Domain x cannot equal -6 and 6. Oops. Right. And range y cannot equal 1 and 5/12. Alright, so graphing, we go x-intercept at 1. We have vertical asymptote at -6. Horizontal at 1. And we have a hole at 6 and 5/12. So 5/12 is roughly here, so we're just going to draw a circle there. So we have our hole here and our x-intercept, so we know we have a curve in this quadrant of the graph. And now we need to find this. So we have a 7 here we need to plug in to find. So 7, we get 6 on the top and 13 on the bottom. So 7/13. So that's going to be right here. So we know our curve is here. Okay, so that's why we need to double check. All right. Go ahead and skip those checkpoints real quick. I just want to talk about this last one. This is going to be pretty quick. So we're looking at a graph, and we need to be able to identify our key items here. X-intercept. So we have an x-intercept at x equals 2. We have a hole. So a hole shown right here. So open circle. We really don't know what the y value is. We don't have a function, so we really can't tell. So we're just going to say hole at x equals 3. Vertical asymptote, if we look close, we can tell that it would be right here. So at 1. So vertical asymptote at 1, and then the horizontal, if we look at the graph, we can tell that it is at y equals 1. Alright, so that's that for graphing rational functions. So let me know if you have any questions, but attempt the homework, and we'll talk later.